Good evening. I think we have to solve sum number 6 from which exercise? From I think 2.3. Sum number 7. The midpoints of the sides of a square of side 1 are joined to form a new square. This procedure is repeated indefinitely. Find the sum of number 1, the areas of all the squares. Second, the perimeters of all the squares. Now, area of the square of side of one unit is what? 1 square. If x is the side of the second square, then clearly x square equal to what? Half square plus half square, right? And therefore it is again 1 by 2. So what is x? It is 1 by 2. See, from the diagram it is clear. Now this is the side of the second square. So what is the area of that square? It is 1 upon 2. If y is the side of the third square, then what is y square? It is again 1 upon 2 root 2 square. Why 1 upon 2 root 2? See, from 1 we divided by 2. Okay. And then we get x as 1 upon root 2. So for next, I divide this by 2. So 1 upon 2 root 2 square plus 1 upon 2 root 2 square is y square, side of the third square. So square of that is 1 by 4. So side is half. So what is the area of the third square? It is 1 by 2 square and so on. And therefore, sum of the areas of all squares will be what? 1 plus half square. Note that this is infinite GP with a equal to 1. And what is r? R is 1 by 2. Now modulus of common ratio is less than 1. So sum to infinity exists. And what is s in that case? S is nothing but a upon 1 minus r, that is 2, after substituting the values. And therefore, the conclusion is sum of the areas of all squares is nothing but 2 square unit. So this is the first part. Now what about second? What is perimeter of a square? It is 4 times side. So perimeter of the square of side 1 is 4. The side of the second square is 1 by root 2. So what is the perimeter of second square? 4 by root 2. The side of the third square is half. So what is the perimeter of the third square? 4 by 2 and so on. So sum of perimeters of all the squares, take 4 common. So 1 plus 1 by root 2 plus half up to infinity. Now can I write half as 1 by root 2 square? Actually I need not, because I can say that these are in geometric progression with first term 1 and common ratio is 1 by root 2, right? Now what is the modulus of common ratio? It is less than 1. So sum to infinity exists and it is given by a upon 1 minus r. Substitute the values to get what? Root 2 upon root 2 minus 1. So from 1, see, don't write this as final answer because we have taken 4 common and this is sum of these terms only. So from 1, what is sum of the perimeters? It is 4 root 2 upon root 2 minus 1 units. Okay. So this is about the solution. Sum number 8, a ball is dropped from a height of 10 meter. It bounces to a height of 6 meter, then 3.6 meter and so on. Find the total distance traveled by the ball. Actually, we cannot solve this for the reason a ball is dropped from a height of 10 meter. So it covers 10 meter, right? And then it bounces to 6 meter. Again, when it touches ground, 6 more meters are covered and then it bounces to 3.6 meter. Now, bounces are given as 3.6 meter. They haven't said that these are in geometric progression, right? So we cannot conclude that the next bounce will be 3.6 into 0.6, which is actually the ratio of 3.6 and 6, right? But if we consider that, then we can say that 10, but 10 is to be considered once, not twice. So 10, then 6, 3.6, they are given in GP then we can say that 2 times in bracket 10 plus 6 plus 3.6 and so on. And from that, you have to deduct 10 because 10 is to be considered once only. Okay, so at present, we will not write the solution. Now we discuss harmonic progression, which is called as HP, standard short form. Now observe the numbers 1 by 7, 1 by 10, 1 by 13, 1 by 16. Are these terms in arithmetic progression? No, they are not. Why? Because the difference is not constant. Are these terms in geometric progression? They are not. Why? Because the ratio is not constant. Same is the case with these numbers. But you will notice that next term in this particular sequence is what? 1 upon 19, right? And in this case, it is 1 upon 9. How? See, if you consider the reciprocals of these numbers, they will be 7, 10, 13, 16. Note that 7, 10, 13, 16 are in arithmetic progression. And we have ready-made formula to find the nth term of an arithmetic progression. Or as far as this sequence, this AP is concerned, the next term is obtained by adding 3 to the previous term. That is, common difference is 3. So for an AP, next term is 19. So for corresponding harmonic progression, next term is 1 upon 90. What about these 37, 30, 23, 16? Yes, these terms are also in arithmetic progression with common difference what? 30 minus 37, that is minus 7. Okay. So add common difference minus 7 to 16 to get what? 9. So this is next term of an AP. So it is the next term of corresponding HP harmonic progression. It is nothing but 1 upon 9. Okay. So how will you define HP? The definition is a sequence T1, T2, T3, and so on, where Tn is not equal to 0 because reciprocal is involved, right? Is said to be in harmonic progression, that is HP, if 1 upon T1, 1 upon T2, 1 upon T3 are in arithmetic progression. Same example, or I can take many more rather. 1, 4, 7, 10 are in AP. Yes or no? Yes. So can I say their reciprocals 1, 1 upon 4, 1 upon 7, 1 upon 10 are in HP? Yes, they are. Okay. So this is about harmonic progression. Now, can you tell me formula for some of the first n terms of HP? We have ready-made formula for some of the first n terms of an AP. I repeat the question. Can you tell me formula to find some of the first n terms of HP? Yes, anybody? I hope you got my question. Can you tell me the formula to find some of the first n terms of harmonic progression? Yes, anybody? See, some students are saying that this is the formula. No general formula to find the sum of n terms of harmonic progression, for the simple reason. See, these terms are in HP. Suppose we are asked to find sum of these 4 numbers. Will you say that take reciprocals because they are in AP, add them, 10 plus 7, 17 plus 4, 21 plus 1, 22. So sum of their reciprocals is 1 by 22. No. So you have to remember that we cannot find, there is in fact no general formula, I mean, to find some of the first n terms of harmonic progression. Okay. Now after that, by all means, we have to discuss three means. That is arithmetic mean, then geometric mean, and then harmonic mean. These are three important means. Now we are going to discuss these three means and relation between them. There are two interesting theorems. They will give us relation between these three means. Okay. So we discuss these one by one. First is arithmetic mean. Now we are going to denote arithmetic mean by capital A. Okay. Now, how will you define arithmetic mean? Definition is very simple. If A, small a, capital A, small b, are in AP, then the middle one is called as an arithmetic mean between A and B. Now, B are in AP. Therefore, capital A minus A is small b minus capital A. So what is 2A? 2A is nothing but A plus B. So what is capital A arithmetic mean? A plus B upon 2. So arithmetic mean between any two numbers A and B is A plus B upon 2. Now you have to remember the next definition. Suppose A, A1, A2 up to AN and then B are in AP. Then A1, A2, A3 up to AN are called as n arithmetic means between two numbers A and B. I repeat, if A, A1, A2, A3 up to AN, B are in arithmetic progression, then A1, A2, A3 up to AN are defined to be, are called as n arithmetic means between A and B. For example, because in exam you may be asked to introduce three arithmetic means between any two numbers. In this case, consider 7, 10, 13, 16, 19. See, there are three numbers. Basically, these are in arithmetic progression, right? So the three numbers between first and last of this AP are termed as three arithmetic means between 7 and 19. You may say 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. These are also in AP. So all the numbers from 8 to 18 between 7 and 19 are also called as arithmetic means between two numbers 7 and 19. Is that clear? So this is about arithmetic mean. Now then, second mean is geometric mean. Usually we denote it by capital G. Now how geometric mean is defined? If three numbers A, capital G, B are in geometric progression, then G is called the geometric mean of A and B. Now A, G, B are in GP. So I can say that G upon A is same as B upon G. Cross multiplication gives G square equal to AB. So what is capital G? It is plus minus root AB. Now we have to use common sense. As root AB is there, clearly A and B have the same sign. That is, both A and B are positive or both are negative. Okay. In this case also, if A, G1, G2, G3, Gn, B, if these are in geometric progression, then G1, G2, G3 up to Gn, these n numbers are called as n geometric means between A and B. In exam, you will be asked to introduce n number of geometric means between any two numbers. How to solve that is different thing, but you should know the definition. Because some students ask me, how can there be 4 or 5 geometric means between any two numbers? The logic is simple. If A, G1, G2, G and B, these are in GP, then the numbers between first and last of GP are defined to be geometric means between first and last numbers. Okay. Now, the third one is harmonic mean. Now, you have to answer this question. Basically, harmonic mean HM is denoted by capital H. So, if AHB, what are the restrictions on AHB? Clearly, A and B are not zero, so that H won't be zero. So these are in HP. Then H is called the harmonic mean of A and B. Now my question is, can you obtain the formula for harmonic mean? That is, how will you express capital H in terms of A and B? Because see, for two numbers A and B, arithmetic mean is A plus B by 2. Geometric mean is plus or minus root AB. So can you tell me the formula for harmonic mean? What will be capital H? Type your answer in chat box. Yes, you are absolutely right. AHB are in harmonic progression, right? So 1 upon A, 1 upon H, and 1 upon B are in arithmetic progression. So 1 upon H is arithmetic mean between the remaining two. And we have the formula. What is arithmetic mean between A and B? It is sum upon 2. Okay. Now, how to solve this? It is B plus A upon twice AB. But we are not interested in 1 upon H. We are interested in H. So take the reciprocal. So H is twice AB upon A plus B. See, you have to remember this as standard formula. So for any two numbers A and B, arithmetic mean is A plus B upon 2. Geometric mean is plus minus root AB. And harmonic mean is twice AB upon A plus B. Is that clear? Now, if we consider general case, because if you are given n numbers, okay, suppose numbers are, do not write this, everything is there in that PDF file. Suppose x1, x2, x3 up to xn are n numbers, then arithmetic mean is what? You know how to find mean. Add all the numbers, x1 plus x2 up to xn upon n. This is defined as arithmetic mean. Secondly, geometric mean, there are n numbers. So we say take nth root of what? The product x1 into x2 up to xn. This is geometric mean. And what about harmonic mean? Harmonic mean H is how many numbers? N. So n upon 1 upon x1 plus 1 upon x2 up to what? Up to 1 upon xn. Okay. Now the last part, then we can solve sums on harmonic progression and three means. We are going to prove two important results. Let me explain. Suppose A, G, H are arithmetic mean, geometric mean, and harmonic mean of two positive numbers, respectively. Then we have to prove that G square equal to AH. And second interesting result, harmonic mean less than or equal to geometric mean less than or equal to arithmetic mean. I repeat, if AGH represent arithmetic mean, geometric mean, and harmonic mean respectively of two positive numbers. I'm not saying unequal. They are positive numbers. They can be equal. In that case, G square is H, and second, arithmetic mean is probably the greatest. So A greater than or equal to G, greater than or equal to h. Okay, good. Now how to prove these results? Proof is simple. Just listen to me because this is also given in the PDF. Suppose two numbers are a and b. Okay, then we know that what is arithmetic mean? A plus b upon 2. Then what is geometric mean? We consider positive root AB. And what is harmonic mean? We have just proved this result, twice AB upon A plus B. Okay, so these are the three formulae. Let us verify the first one. First part, what is A into H? It is A plus B upon 2 into twice AB upon A plus B. Simplify, A plus B gets cancelled, 2 gets cancelled, AB. Can I say that AB is root AB square? Yes, but root AB G, so G square. In other words, listen to this carefully. In other words, I can say that geometric mean between arithmetic mean and harmonic mean. Means what? G square equal to AH. Can I write this as G upon A equal to H upon G? Yes, I can. Right? And therefore, I can say that geometric mean is geometric mean between remaining two means, because G square comes out to be AH. Okay? Yes. So this is the first part. Now, second part is interesting. In exam, you may be asked to prove this. Let us find A minus G. Okay. What is capital A? Now, why to start with this only? Then only we get the answer. There is no other reason. So A is A plus B by 2 minus root AB. What is LCM? 2. Now, can I write A as root A square? Yes, I can. Can I write B as root B square? I can. Just a minute. There is one more term. Okay. Minus twice root AB. Now you will notice that numerator is square of what? Root A minus root B. Denominator as it is. Do you agree with me? Now square is never negative. It can be 0, but 0 is neither negative nor positive. Right? So can I say that A minus G is greater than or equal to 0? Usually it is greater than, but if two numbers are equal, difference will be 0. But otherwise, A minus G is positive. Okay, so that gives me A greater than or equal to G. Okay, now we have just proved, or before that, let me divide by G. See, in case of inequality, if you divide by positive number, inequality remains the same. Okay, so A greater than or equal to G, that is A upon G greater than or equal to 1. I hope you understand this. Now we have just proved what? G square equal to H. First part we already proved. Now from this, can you tell me what is A upon G? Rearrange the terms. A upon G is nothing but G upon H. So if A upon G is greater than or equal to 0, can I say G upon H? G upon H is greater than or equal to, not 0, greater than or equal to 1? Yes, I can. See, we have already proved that A upon G is greater than or equal to 1. But A upon G itself is G upon H. So can I say G upon H is greater than or equal to 1? I can. And therefore, from this, I say A greater than or equal to G and G greater than or equal to H. Can I combine these two? I can. So A greater than or equal to G greater than or equal to H. If you want to begin with H, no problem. H less than or equal to G less than or equal to H. That is, amongst the three means, arithmetic mean is the greatest provided two numbers are unequal. See, if you take two equal numbers, say 4, 4. What is arithmetic mean? 4 plus 4 upon 2, that is 4. What is geometric mean? Root 16, that is 4. What is harmonic mean? Twice AB upon A plus B. So 2 into 4 into 4, that is 32 upon 4 plus 4. So again 4. So if two numbers are equal, these are equal. 3 means. Otherwise, arithmetic mean is the greatest. Exercise 2.4. First question, we'll be doing first and second part, third part for homework. Verify whether the following sequences are HP, harmonic progression. Okay. So terms are, write down, terms of the given sequence are 1 upon 3, 1 upon 5, 1 upon 7, 1 upon 9, etc. Reciprocals are, write down. See, presentation is important. Reciprocals are 3, 5, 7, 9. These are in AP. These are in AP. Now you need not write this actually, that A is 3, D is 2, because we are not asked to find the nth term, right? Therefore, given sequence is HP. This much is sufficient. Now tell me about second. Now for the sequence 1 by 3, 1 by 6, 1 by 12, 1 by 24, what are the reciprocals? 3, 6, 12, 24. Now 6 minus 3 is not the same as 12 minus 6. So terms are not in AP. So the reciprocals cannot be in HP. So the given sequence is not HP. Third is for homework. The answer is yes, they are in HP. Now second question. Find the nth term and hence find the 8th term of the following harmonic progressions. Again, we'll be doing first and second, third for homework. So 1 by 2, start writing. 1 by 5, 1 by 8, 1 by 11 are in HP. Therefore, 2, 5, 8, 11 are in AP. Small a, that is first term is 2. What is common difference? 5 minus 2, that is 3. Therefore, for an AP, what is nth term? A plus n minus 1 into D. That is 2 plus n minus 1 into 3. Simplify this. So it is 3n minus 1. I hope you're getting this. Therefore, for HP, Tn is 1 upon 3n minus 1. You can verify this. What is third term as per this formula? 1 upon it. Is third term given to be 1 upon it? Yes, it is. Means what we have opted is correct. We are asked to find 8th term. So it is 1 upon 3 into 8 minus 1. That is 1 upon 23. Okay. In fact, second and third, I hope you can do on your own. Simple one. It's not at all difficult. So I'll give the answer. For second, it is 1 upon 2n plus 2. So clearly, it is 1 upon 18. And for the third term, for the third term 1 upon phi n, so that eighth term is 1 upon 40. Right now. Actually, these two sums were given for homework. Exercise 2.3, question 6. This is the second part. And this is the third part. Actually, there was fourth part also. Okay. So that's it for today.